Okay. Let's say if we wanted to pick a good example here. Find the value of x if, say for problem A, log base x of 49 equals 2. And let's say for problem B, log base 4 of 1. Oh, sorry about that. And I'll let you start on this one. I'll give you a hint for B. Whenever they start off like this, you can always just rewrite as log base 4 of 1 equals y. Okay. So whenever they don't give you an equal to, you can always make it equal y. Oh, sorry, it should have been x. It said solve for x. But if you want to make it y, you could. At least that's what I usually do. Alright, so let's solve these two. We'll start with A. So log base x of 49 is equal to 2. Remember the x is your base. The 49, that's in your x position. And the 2, that's your y. B to the power of y equals x, just your base, or x position. I don't really like that. Actually, I'll change that because that's going to be confusing. instead, I'll make that log base b of 49 equals 2. Just to avoid having x's all over the place. Okay. So if you have your base, and I'll change that to b there. Okay, so if you have your base, remember that's equal to, actually if I have it here, I don't need it there. There we go. Okay. So if you have your b to the power of y equals x, it's going to become b to the power of 2, or b squared, equals 49. Okay. And that looks like, and yeah, make that look clear. There we go. Okay. So b squared, if we square root both sides, b equals positive or negative 7. So b equals 7 or b equals negative 7. But we know your base has to be greater than 0, so that negative 7 isn't even an option. So that's your only answer. All right. So any questions on that one? Like I said, normally I would change that to b. I'd change, if it's equal to, I'd change it to y. It kind of depends on if you're comfortable knowing that there's an x here and you're solving for x and it's bouncing around. Okay, so for problem B, log of base 4 of 1, you can make that equal to y, or you can leave it as x. It's all up to you. Whichever method makes you comfortable with it. Okay, so if we use this one, 4 is your base. That's more your x position. And of course the y is your y. Okay. Means b to the power of y equals x will become your base, which is 4, to the power of y equals 1. So make that look more like a y. Here we go. Okay. Now with this one, you just have to remember, and I'll put it over here. Anything to the power of 0 is going to equal 1. So if we have 4 to the power of 0, that's going to equal 1. Okay, so we can rewrite this as 4y equals 4 to the power of 0. Okay. Again, our bases are the same, so this is only true if your exponents are equal. Okay, so that means that your y equals 0. Or your x equals 0 if you kept it the first way. All right, so any questions on that one? Okay. So like I said, normally when I was first learning it, I would always just convert it to b, y, and x, just depending on what position it's in. But once you get comfortable with it, it won't matter if it's an x there or whatever, you'll still be able to solve it. All right. That one already. Oh, do you have a question? Oh, okay. You're just stretching. All right. So let's look at properties of logarithms. Now these first two properties you really don't have to memorize as long as you know the b to the power of y equals x. They kind of explain themselves. But it's one of those, it's good to know but not really necessary kind of things. Okay, so if you have log of some value a, log of base a of 1 equals 0, and log of base a is equal to 1. Okay, so these two are your properties, but really if you look at them, your base to the power of 0 is equal to 1. So any a value you have to the power of 0 would equal 1. And for this one, any base you have here to the power of 1 will equal the same thing. So that's why I was saying it's not really necessary to memorize these, because they're just repeating the same thing over again, but just pointing out a pattern. Okay, so if you have a to the power of log base a of x will equal x, and log of base a of a to the power of x equals x. And again, these two are really the same thing. A to the power of x equals log base a of x. So if you kind of look at this, so if you kind of convert this to b to the power of y equals x, your base is a, so that would be log base b of x equal y. So in this case, like I say, your base is a, so that's log base a of x equals log base a of x. Okay, so like I said, it's kind of a play on what you've already been doing. And for this one, a to the power of x equals a to the power of x. All right. So like I said, if you wanted to memorize them, you could, but it's not really necessary. Okay. Now another property, I'm going to start on a new sheet. Everyone's still writing. Oh, looks like everyone's done. Okay, and next we're going to look at natural logarithms. Okay, and natural logarithms, well, not to say the value, let's say the function 1 plus 1 over n to the power of n. Okay, so let's say if we decide we're just going to plug in our n values. Okay, so if we decide we're going to draw a chart here where this column represents our n values and this represents our 1 plus 1 over n to the power of n. Oh, that's a little crooked. It's a lot of crooked. There we go. That's a little better. Not much better, but a little better. Okay, so let's say if we make n equal 1. You have 1 plus 1 to the power of 1, so we have 2. Let's say if we make n equal 2. 1 plus 1/2, which is 3 over 2 to the power, that's 2.25. If you plug that into your calculator. Okay, so let's say if we make n equal 4. We would actually end up with 2.4414, and it keeps on going and going and going. Okay, so if we make n equal 12, so that would give us 2.61303, and it keeps on going and going forever. So if we make n equal, say, 365, that would be 2.714, 567, and it keeps on going forever and ever and ever. Okay, so if we let it equal 1,000, just going up, 2.7169, 239, and it keeps on going forever. What if we let it equal 100,000? That would be 2.718, 268, and it keeps on going and going and going. What if we let it equal 1,000,000? So that's 2.718, 28137, and it keeps on going and going and going. Okay, so as n gets bigger and bigger and bigger, in other words, let me bring that down a little. As n approaches infinity, and when they say n approaches infinity, you'll sometimes see n approach the little infinity symbol. One plus 1 over n to the nth power gets really, really close to 2.718, and it keeps on going and going and going, but it just gets really, really, really close to that number. It doesn't grow a whole lot bigger than that. Okay, so this value, 1 plus 1 over n to the power of n, as n approaches infinity, equals the value e. Now in this case, e is an actual real number. It's just this value as n keeps getting bigger and bigger and bigger. So when you see that e on your calculator, this is it. Okay, so let's say instead of n, if we decided to use x, so f of x, e to the power of x, is called the natural exponential function. Okay. Now the thing that kind of makes e special is that if you make your base equal e, then that means if you have the log of base e of x would actually equal what we call, that's just an L. I didn't want to draw it to look like a 1, so I just made it in cursive. Natural log of x. Okay. So the difference between just a regular log function and a natural log is that your base is equal to e. Okay, and it's defined when x is positive. So if your x is negative at any point, it's undefined. All right, so any questions on that so far? All right. And I'll put that on another sheet. Leave that up for a few more seconds. All right. Okay, so the value e and natural log actually will cancel each other out. Okay, so in other words, if you have e and it's raised to the power of natural log of x, the e and the natural log will cancel out, and it's just equal to x. Okay. Same thing if you have the natural log of e to the power of x. The natural log and the e will cancel each other out, and you end up with x. Oh, bring that down some. Okay, so let's say, for example, if you have the natural log of e, you could actually answer that without really doing a whole lot. Just remember, e is equal to e to the first power. So that becomes the natural log of e to the first power. Remember, that natural log and e will cancel each other out. So you end up with 1. Okay. So what if you had the natural log of 1 over e squared? Okay. So this one, 1 over e squared, is just e to the power of negative 2. So that means you could rewrite it as natural log of e to the power of negative 2. These two, once again, will cancel each other out. And you're just left with negative 2. All right, so any questions on that so far? All right. Okay, so let's say, for example, actually we did a couple of, not examples, we can probably move on to the next, we did those. Yep. Leave that up for a few more seconds. Alright. Now we're going to just cover common logarithms. Okay. Let's say when a logarithm does not have a base, you can just assume that that base is equal to 10. Kind of like if you have a square root, you just assume that the index is a 2. Okay, so this is called a common logarithm. So if you have, in other words, just log of x, then that's the exact same thing as saying log base 10 of x. All right, so let's say, for example, if we wanted to evaluate, say for problem A, log of 1,000. Say for problem B, log of 1 over 100. Say for problem C, log of 10. If I leave that, I'll do the other 2 examples on the next one. I'll leave it for those 3 for this one. Okay. So for A, remember there's no base, so we just fill it with 10. So log of 1,000, it just becomes log base 10 of 1,000 equals y. Because remember, we want to have our b to the power of y equals x. So even if they don't give you an equal, just make it equal to y. Okay. So our base to the power of y equals 1,000. Okay, so that's 10 to the power of y equals 1,000. Okay, so we know that 10 to the 4th power is 1,000. 10 to the 3rd power, sorry about that. Forgot how many zeros gives you how many, what the exponent is. 3 zeros is raised to the 3rd power. Okay, so that gives us 10 to the power of y equals 10 to the 3rd power. Again, base is the same. This is only true if your exponents are equal. So it means that y is equal to 3. And remember, y is just your log base 10 of 1,000. So your log base 10 of 1,000 is equal to 3. All right. So any questions on that one? Okay. So let's do problem B. Log of 1 over 100. We can just rewrite that as log of base 10 of 1 over 100 equals y.